For this problem, we are asked to write two equations to model the scenario. So in our scenario, child counted his money and had 22 coins. He asked his mom to help him count his money. She came up with $4.45 worth of quarters and dimes. So as I start to write this scenario, I'm going to let D equals dimes and Q equal quarters as my two variables. So I have two different ways of counting the money. And so the first way is the way that the child counted his money. And so he just counted each item. So he counted each dime as one and each quarter as one and came up with the total amount being 22. And then the mom came in, and when she counted the money, she was counting the value of the money. So when she counted a dime, she counted it as 10 cents, so 0.1. And when she counted a quarter, she counted it as 25 cents, so 0.25 for each quarter. And so she came up with $4.45 as the value. So that's the first thing. Write two equations to model. I have an equation based on how the child counted, and I have an equation based on how the mother counted. Then it asks me how many quarters and how many dimes did the child have, and use the elimination method. So I'm asked to solve these two equations together as a system of equations, and I'm told specifically to use this elimination method. So the elimination method is all based upon trying to eliminate a variable. And the way that we do that, you can see that my equations, the D's are lined up, the Q's are lined up, the constant terms are lined up. And so what I'm going to do is to multiply this first equation by something so that when I add my columns, one of my variables will be eliminated. So that's a lot to think about, and we'll talk about it in detail as we go through it. So I see that in the second equation I have 0.1D. So if I took this entire first equation and multiplied it by a negative 0.1, I would have the additive inverse, the thing that would add up to make D cancel out. So when I go to do this, you see that I put parentheses around the entire equation. We know that when we do something with an equation, we have to do the same thing to both sides. So it's truly, I would be taking this side times negative 0.1 and this side times negative 0.1 so that I am keeping my equation completely balanced. So I'm going to go down here where I have a little bit more room. So multiplying through, and the first time I do the distributive property, so negative 0.1D minus 0.1Q is equal to, and I would take negative 0.1 times the 22 and get negative 2.2. Okay. I'm going to keep my second equation exactly the same. So I'm right below it, I'm writing my second equation, which was 0.1D plus 0.25Q is equal to 4.45. Okay, so far I've done legitimate algebra because we know that we can multiply both sides of the equation by the same amount. And I picked this amount specifically so that when I add my two equations together, the D's will add up to 0. Okay? Now I'm going to add my two equations together, and this is where it feels like, how is that legitimate algebra? So we know that when we're solving an equation, we can add the same amount to both sides. Since this side of the equation equals that side of the equation, when I add this equation, I'm adding literally the same amount to both sides. It's just represented differently. So I have to add like terms, so I add these together and that truly cancels out, so that is my 0. Add these together, so I type in my calculator negative 0.1 plus 0.25 and I get positive 0.15Q. And I add my constant terms together, and so negative 2.2 plus 4.45 on my calculator gives me 2.25. And so what I have done, and why this is called the elimination method, is because I have eliminated the D from my equation. All I have left is a Q, and it's pretty easy to solve from here. So I divide by 0.15, divide by 0.15, and I get that the quarters are equal to 15. So how many? He has 15 quarters. I do have to go out and figure out how many dimes. So looking back here at the original, he had 22 pieces of money. So 22, subtract out the 15, gives me that he had 7 of the dimes. I can check my work. So 7 dimes, I know would be 70 cents, 0.70. 15 quarters, well, that would be almost $4 because 16 quarters would be $4, so $3.75. And then if I add these up, 4, carry the 1, $4.45. So it definitely checks out with how the child counted, because if I add these up, I have 22 coins. And with how the mother counted, I have $4.45 as their value.